Hey, Roman. Right, okay, so I want to give a counterclockwise orientation to the boundary of the triangle with these three given vertices. Okay, so at the level of drawing the thing, it's easy. At the level of actually writing down the parameterization, people often struggle with this. This is often quite difficult. Right, so we draw the region. Right. And now we want to draw arrows so that it looks counterclockwise. So far, so good. Okay, and now for the hard part, which is to write down the actual parameterization. So actually write down the parameterized curve that does this. This is the part that people often struggle with, is writing down a function. So we need a curve that goes from here to here. Okay, so we'll make C of t be our parameterized curve. Okay, so we're going to start off here, and we drive in our little car over to 1. Now we want to continue on our journey. Right, we get to here, and now we want to continue north to 1, 1. Okay. TT, right? If we did that, right, we would. So yes, okay. So good guess. 0t, right? Aha. So actually, you know what? This is a fun game. So try and write down the next step. Okay, so we're going to do, okay, so try and write down this thing. Okay, everyone finds this hard.
Because x means 1, you're just moving the y direction. 1t. And then that will be minus t, because this t is the x, represents the x. You know, it's an xy coordinate. So from 0 to t, 1, 0, y remains 0. So x is 0. X is the parameter. From 1, 0 to 1, 1, y is remaining the same. Only x is changed. Oh, sorry, x remains the same. Y is changing. So 1, t. And then as we go down, both are changing. So suppose instead of 1, 0, 2, 0, 0. Then I'll do 2, 2, 0. And then downwards, I think I should minus the minus. Because you want to go down. Down and both are changing. Like in any instance.
Right. So before it happens before you do 1, then you get. Right. So. Yeah, you're trying to find a curve. You're trying to find like a parameterized curve. Yeah, this will give a.
But then what about 1 0?
Yeah, let's call because then it'll be 0.5.
T होगा ना?
Like T minus.
Wait, sorry, 1 second.
लेकिन वो तो 1 से 2 तक जा रहा है।
Right, yeah, T minus 1.
क्या हुआ? अब देखो ना
T minus 1
देखो जो 1 1 होगा 1 2 होगा
1 T minus 1 और 1 T minus 1 और वापस जो नीचे आ रहा है वो y is equal to x वाली लाइन है बेसिकली।
हाँ 1 t minus 1 yes.
Okay, so we're looking for this leg of the journey, right? From 1 0 up to 1 1. Right? We want to go north on 60. So notice that the x coordinate stays the same the whole time. So we already have the x coordinate. Right? We go from here to here. Now the issue is that our y coordinate's changing. Yeah? Yeah.
Oh yes. Oh yeah. I was just
Okay,
saying.
good. Okay, so our issue is that our y coordinate's changing. It starts off at 0 and it goes to 1. So what we want to do is we start, however, t starts at 1 and ends at 2.
T minus 1.
Yay, t minus 1. Indeed. Right. How on earth would you come up with this? Right? It's crazy. Right? So what you need a function that goes from 0 to 1. When does it go from 0 to 1? When t is equal to 1, t equals to 2. So what you do is you subtract 1 from these values.
Yes.
And then they match where you want to go. Okay, nice. So we've gone here to here, here to here. Okay. Now we want to go backwards. We want to go from 1 1 all the way down to 0 0. And we want to do that in the time from 2 till 3.
negative T minus 2
Okay, so we start here at
वो दोनों change हो गए ना.
t equals 2.
हाँ तो
2. And then we get to 0 0. So now we need another function here.
Wait.
Yes.
negative
3 minus t. Yes, that will do. Yes.
negative T minus 3
Nice.
क्या है कैसे?
Beautiful. And this is our parameterized curve. Yes.
Does the t's have to be like from 0 to 1, or can it be from 0 to 2 and then 2 to 4 and then 4 to 6?
Yeah. So yeah, there's infinitely many choices of this function. There's many ways to choose this function.
T minus 2.
If you really want to trip out the grader,
negative T minus 3
you could put like a squared there.
Plus 3 है ना.
Right? So there's many
negative
choices
whole
here.
whole
By
negative whole T
convention,
minus 3
I choose that
plus हो
each
जाता है
segment
ठीक
gets 1 unit of time. So this takes an hour, this takes an hour, this takes an hour. So it's just a convention to choose these in this way. There's infinitely many choices that'll all parameterize the thing equally. Nice, okay, great. Once we've got one of these, it's important to check that it really works.
अगर इसको minus t plus 3
So C of 0, or under this function, C of 1, or in this function, C of 2,
जीरो और वन के बीच में है
okay. Right, this thing goes to exactly the points we want, yeah?
So I wonder for the t, does it have to, is it like 0 less than or equals to t less than 1? Well,
Aha, right, so the question is, yeah, could we replace these with less than signs?
or wait,
Like that?
actually no, the greater the sign. So, how I write this?
And what do we want here?
This one will be less than or equals to, but then the one previously.
Previous.
It will be 1, so it will be 1 less than t, less than or equals to 2. Yeah, that's my thought.
Like that?
Okay, oh no, by over.
Like
I
that?
was wondering, like, I was worried about it being overlapped.
Right, right. Oh, I see. Okay, so that's the question is, what about these overlaps, right? So if we have less than or equal to here and here, then the question is, well, these two functions overlap, and that's good. We want that. Okay, you get the exact same curve. You get the exact same curve if you switch these to right, you get the exact same curve. If you switch these to less than signs, it's all good. Okay? You're now mathematical grown-ups, and you can make these kinds of choices. There's infinitely many ways to parameterize this thing. Yeah, there's a question back there.
The last one doesn't work. It's less than 3, you cannot choose 3.
But we've already covered that point by 0.
Yeah, but it's like 3 minus t, right? We need t to be 3.
No, but we've already got that point. We've got the point 0, 0.
Okay, then we don't-
Right? So, right, it's okay if we
Oh, it doesn't
lack 3 because we already covered it as 0, 0 once. So, right, if we forget about that last instant in time, when you arrive back home and you go, and that's fine.
Doesn't that show that like it may be discontinuous because it's not actually overlapping? Maybe we can assume that it is, but it doesn't actually prove that it is.
So, right, so yeah, you raised an important issue. This thing has to be continuous, okay? I know someone in this room is gonna sneak up to me in my office hours and say, hey dude, yo man, what? Let's say, our textbook says it doesn't need to be continuous. It needs to be continuous, okay? So, must be continuous as a parameterized curve. Okay, so now I want to say what we can use these things for. Right, we've come up with this parameterized curve, and now I want to say, like, why are we doing this? we'll integrate out this particular function over this boundary. And so in order to do so, we've got these three arcs, and we'll integrate over those arcs. So the first part is over T0, or parameterized curves T0.
Isn't it 3, 2 at the end?
Oh, thank you.
2 to 3.
Thank you. Right, so we parameterize T0, so we have zero dt